Hi, my name is Daniel Relsbeck. Today I will be talking about Cisco switching. Hope you enjoy the presentation. I am going to be using Lab 3.1 from the Switching Foundation Learning Guide. This lab specifically focuses on building VLANs and managing them with VTP. Now you can see that I am setting up and completing the lab in the background of this presentation. Don't worry, you won't miss anything. I will stop and highlight major points that will be covered in the presentation. Before we go any further, it is important to note that in order to get the most out of this presentation, you will need the basic knowledge of VLANs and VTP. Some notable pages from the textbook that will better your understanding of the lab will be Chapter 3, page 42. This will be an overview of VLANs. Also, Chapter 3, page. This one will be an overview of VTP. First, we are going to be looking at VLANs. On page 42, it states, a VLAN is a logical broadcast domain that can span multiple physical LAN segments. My favorite example of a VLAN network is a high school hallway. In our first example, we have one hallway for traffic. In order for students to get from one class to another, they need to travel through this passage. The route includes freshmen, sophomores, juniors, and seniors. Because there are so many students using one hallway, it becomes inefficient to travel to each class. Now, in our second example, you can see we have divided the hallway up a bit. We have given each class its own passage to travel through. This not only creates a more efficient way to travel, but it also reduces the time to mediate an issue that would be caused during student or data exchanges. Next, we will be moving to VTP. On page 70, it states, VTP is a layer 2 protocol that maintains VLAN configuration consistency by managing the additions, deletions, and name changes of VLANs across the network. During the VTP process, a server will be assigned to manage the VLANs. It will pass out the VLAN information to all of the clients, similar to how a teacher would hand out notes to all of their students. And now that we have reviewed the basic definitions of VLANs and VTP, we can move on to the objectives of the lab. Objective A, create VLANs for each department of the building. The most important commands from this objective include A, VLAN X. X represents a number to classify the VLAN. B, name, then the name of the department. Objective B, configure VTP to share the information with each of the switches. The most important commands from this objective include A, VTP server or client. A VTP server is where the VLANs are set up, and a VTP client is who receives the VLAN information. B, VTP password. This allows the VTP client and server to connect to the clients. Take note, if a VTP password has not been set and a new switch is connected to the network, there is a possibility that all the VLANs will be erased to follow the switch with the correct revision number. Once we have completed all the objectives, we can move on to the fun part of the lab, extending it. Our new objectives of the lab will be A. Adding one VLAN for phones. B. Allowing a computer to be ran through a phone to the switch, but the computer will not be tagged in the phone VLAN. To start, the added equipment for the lab will be one Cisco IP phone. In a real-world situation, we would need to configure Call Manager and install voice cards in our routers. However, for this lab, we will pretend that this has already been done for us. The new commands that will be used are switch port mode access. This command will allow the port that we are using to be placed inside of a VLAN. Second, switch port access 110. This command will push all non-phone traffic through VLAN 110. Last, switch port voice VLAN 10. This command will push all phone traffic through VLAN 10. There are a couple requirements that are needed in order for this to work. The first being that all networking equipment must be Cisco equipment. The second being that CDP must be enabled on your switches. This is how the switch detects whether the incoming packets are voice traffic or data traffic. If you would like to read more about this subject before we move on, you can find valuable information on pages 67 and 68 in your Cisco switching textbook. Before we start making changes to the lab to include the IP phone information that we covered, I would like to share some of the issues I ran into while extending the lab. The first issue I had was that the lab had you change the primary VTP server. When I went back to add the new VLANs to the switch, it prevented me from making VTP changes because it was not the primary server. The command to set VTP server to primary is VTP primary server. Now I did issue this command, but I forgot that you had to press enter to confirm your change. The second issue I had was that the VTP clients were not updating as fast as I would have liked them to. A workaround for this issue is that you can set the client back to transparent mode. Transparent mode will clear the current VTP entries. At this point, you can change the VTP mode back to client mode and it will pull the current updated VLAN information. Now let's get started on making our IP phone configuration changes. The first step will be to create the new VLANs. The commands will be as followed: config t VLAN 10. This will be the VLAN ID. Name phone underscore VLAN. This will be the VLAN for the phones. Then exit to exit the VLAN 10 interface. Next we have VLAN 111. Once again, this will be the VLAN ID. Name space computer underscore through underscore phone. This will be the VLAN for the computers that will be ran through the phone to the switch. Once again, exit, so you can exit the VLAN 111 interface. Next, we must select a port to use for our VLAN tagging. In this situation, we will use port FA0/1. To access the port, we will use the command int FA0/1. First, we will apply the computer VLAN to the port with the command switch port access VLAN 111. Next, we must apply the IP phone VLAN to the port. That command will be switch port voice VLAN 10. From here, CDP will do all the work for us. It will look at each packet and decide whether it is a voice packet or a data packet. According to the results, it will either go into VLAN 10 for the voice or VLAN 111 for the data. Finally, let's double check the port to make sure our configuration stuck. Type exit twice, then enter the command show run int fa0/1. This command will show all configuration changes made to fa0/1 port. Remember, do not forget to issue the no shutdown command to turn the port on. Now we are on our final step. Let's check to make sure the VTP server has pushed our new VLANs out to the clients. I'm going to use the show VLAN command to quickly double check the VLANs on each switch. When reviewing the results from the show VLAN command, we can see that the VTP server has successfully pushed out all of the new VLAN information to our VTP clients. This is the last step and we are finally done with our lab. Before we end our presentation, let's do a quick review of what we have covered so far. We used Lab 3.1 for our original lab to build off of. The objectives for this lab are set up a VTP domain, create and maintain VLANs, and finally, configure an 802.1q trunking. Once again, some notable pages from the textbook that we used in the lab are, first, page 42. My favorite segment from this page is, a VLAN is a logical broadcast domain that can span multiple LAN segments. Second is page 70. A good quote from this page is, VTP is a layer 2 protocol that maintains VLAN configuration consistency by managing the additions, deletions, and name changes of VLANs across the networks. The objectives for our extended lab consist of A. Adding a VLAN specifically for phone traffic. B. Allow a computer to be ran through a phone to a switch. The computer must not be added to the phone VLAN and must stay into the computer VLAN. The only piece of equipment we will be needed for our extended lab is one Cisco IP phone. In my opinion, the most important commands from this section that we added are switchport mode access. This command allows us to put the port into a VLAN. Switchport access VLAN 110. This command allows the data traffic from the computer to go through the data VLAN. Finally, switchport voice VLAN 10. This allows all voice traffic to stay in the voice VLAN. At this point, the presentation is over. If you would like more information on the way voice VLANs work, you can check out page 67 and 68 in your textbook. Thank you so much for taking the time to watch my presentation. I hope you enjoyed it and have a great day.